On today's Visual Studio Toolbox, part one of a two-parter on how you can deliver more value to your end users more efficiently. Hi, welcome to Visual Studio Toolbox. I'm your host, Robert Green, and today we are going to look at how you can get started using some of the basic DevOps practices. Now, DevOps is a hot topic. Lots have been written about it, lots of people talking about it. There are entire Channel 9 shows devoted to DevOps. But it's really important, and I thought we would take an opportunity on Toolbox to look at how you as a Visual Studio developer can get started down the path. Now, the question is, why? What does DevOps offer you? DevOps, one of the key things about it is it gives you the ability to continuously deliver value to your customers. And key point there is the idea of continuously delivering. Now think about apps on your phone. How often do the apps on your phone update? The answer, often. And why is that a good thing? It's a good thing because you're more likely to get bug fixes sooner and you get new features sooner, which all in all is a better experience for you as the customer. Now you as a developer, you should also want to take advantage of this. So consider an application you've built. You and the team just spent a year building V1 of a very important internal application. You release it, and your users are using it. Everybody's happy. Users, being users, they do two things. One, they find bugs that they want fixed, and two, they have feature requests, sometimes large, sometimes small. So if someone comes to you with a bug or a minor feature and says, I would like this updated, what do you want your answer to be? Do you want your answer to be, yeah, we'll fix that bug in the next service pack, which ships quarterly, or, yes, that's an interesting feature, we'll consider that for the next version of the application, which will be 6 months to a year from now. Consider a world, flipping that, where you could say, well, yeah, we do weekly bug updates, so we can fix that bug this week, and we do twice monthly minor feature updates, so we'll take a bunch of features and you can have those in a couple of weeks. Right? The latter is a better world for the customers, who at the end of the day are why you're building software. So how do you do that? How does DevOps enable you to do that? It's a couple key pieces. One is the concept of sprints, which is a fixed period of time in which you're going to do work. So maybe you're on 2-week sprints, 3-week sprints, and at the end of that sprint, you've got some shipping software. It's a very interesting topic, but not what we're going to discuss here. The other part of it is DevOps pipelines, particularly build and release. And what we're going to do in this video and the next one, because I think this will be a two-parter, is we're going to look at build pipelines in this episode and release pipelines in the next episode, also known as continuous integration, continuous deployment, and therefore CI/CD pipelines. And it's basically a way of having machines in the cloud do a lot of the work for you of building an application and then releasing it to test, to production, to QA, etc. All right, so what have we got? Best place to learn about this, of course, is the docs, aka.ms/vst/Azure DevOps docs. The Azure DevOps docs are excellent, and you can learn a whole bunch of stuff in there. All right, so I have an application. It's a very, very simple MVC application built with .NET Framework. It's an ASP.NET application. I could have used Core. I didn't. It doesn't really matter. I have the web app. It's an MVC app. I've got tests. And, of course, I have a grand total of 3 tests. They all pass. The app builds. Everything's good. So if I'm going to build this, then I need the source code to be somewhere that Azure DevOps Services can get to. So I will add this to source control. And what I'm going to do is pick a place to store the code. I could use GitHub. I can use Azure DevOps repos. Both are excellent. To keep things really simple here, I'm going to use Azure DevOps. So I go to my Azure DevOps site, which is rogreen.visualstudio.com. Now, I'm pretty sure if you sign up now, there's a different URL naming scheme, but because I've had this for quite some time, it still uses the old one, rogreen.visualstudio.com, and I'm going to create a new project. And this project will be Toolbox DevOps Show. Okay, I can make it private or public. We'll keep it private. And then I can choose to use Git. I could use TFVC. And I can choose from the Agile, the Scrum, the basic templates here. I'm just going to leave the defaults. And I'm going to create a project. And now this is my central location for doing DevOps, if you will. Okay, there are a bunch of pieces in here. There are boards. This is where you maintain work items and your sprints and your backlogs. And again, that'll be a good subject for a future toolbox. Your repos, this is where we have our code. And then the pipelines is what we're going to focus on. We're going to work on a build pipeline and a release pipeline. You can also do test plans and artifacts, which is a way of managing your NuGet packages. But again, we're going to focus on pipelines. Okay, so we have code in, actually we don't have code in here yet because we haven't pushed it in here yet. So we were in Visual Studio, we said add to source control, and we're going to publish this to Azure DevOps. So what Visual Studio will now do is, based on who I am, go out and find what Azure DevOps organizations I belong to. So I obviously belong to the RO Green visualstudio.com. There's actually a couple others I belong to. And if you notice, this line here keeps moving, so it's going out and searching. It has found a number of organizations. I'm going to pick this RO Green one. And then what I'm going to do, after it connects and brings down information on that, notice that it suggests a repository name of Toolbox Web App, which is actually the name of this application. But in reality, my repo is called Toolbox DevOps Show. So what I really want to do is come in here, choose this Toolbox DevOps Show project, and that gives me the right repository name. I don't want to create a second repository. I want to put it in the existing repository because I created the project first. And now, if I come in here and do a refresh, here's my code in an Azure DevOps repo. Okay, perfect. Now, I'll be checking code into that, and what I want to happen is I want to set up a build. So the first pipeline I'm going to build is a build pipeline, also known as a continuous integration pipeline. A couple places I can do it. I can do it from here. I can click Setup Build, and what I'm going to do is duplicate this page because I'm going to create two of these. So from the code, I can set up a build, and I'm asked what type of application is this. Here are some of the more common ones: ASP, ASP Core, Xamarin, etc. There's a whole bunch more: Docker, etc., Node, and you can get additional ones in the marketplace. But we have an ASP.NET application here. And now what happens is a build pipeline is created using YAML. Now, YAML, some people think YAML stands for yet another markup language. YAML.org says it's YAML ain't markup language. Either way, it's like XML. It is a configuration language. And what we've configured here is a build. So this says trigger on master. So anytime I make changes to master, if I check code into the master branch in my repo, trigger this build. Then grab a machine sitting in a pool of machines. So up in Azure, there's a pool of VMs ready to do my build. And the one, Windows latest, this says there's a machine running Windows Server 2019, also running Visual Studio 2019. So there's a pool of those. Pick one of those machines, then set some variables, then get the latest version of NuGet, do a restore, and then build using these variables. What's the solution? It's star.sln. The build platform and configuration are any CPU and release. And then also run any tests I have. Remember, this application has 3 tests. So this says run those next, all on a server up in the cloud. Now, before we actually take a look at this, I want to show you another way of building a pipeline. So if I come down to pipelines here and I create a pipeline, Again, it asks me where's my code. It also gives me the opportunity to use the classic editor. There's two ways you can do builds. One is in YAML, one is in the classic editor. If you've done build pipelines before, you're more used to the classic editor. YAML is kind of the new way of doing it. But let's go look and see what happens if we use the classic editor. First question is, where's your code? Could be in GitHub, could be anywhere else. Here it's in an Azure repo called Toolbox Show. I click Continue. And now I can create an empty job and build from scratch. I can just go and do YAML, or I can choose what type of application this is. It is ASP, where is it? There it is, ASP.NET. I click Apply. And I'm going to rename this Classic Build Pipeline. And it says grab a pool of agents. The agent pool is the machines that are available. This one defaults to a machine running Windows Server 2016 with Visual Studio 2017. I'm going to choose Windows 2019 running Visual Studio 2019, which is equivalent to this Windows latest in the YAML. Okay. Then we're going to get the sources. We already said that. We're going to get the latest version of NuGet and do a restore, which again is equivalent to this YAML here, NuGet installer, NuGet command. And then this will build the solution based on some variables. Release any CPU, so far the same. Okay, and then this will also run the unit tests. So we're still doing the build, still doing the tests. So far, these are pretty much the same. One big difference, though, is using the classic build. The build pipeline will publish the symbols path and publish the artifacts. And interestingly, the YAML build at the moment does not publish the artifacts, which means when it's time to release this and deploy this application somewhere, like to testing, there's nothing to deploy because you built it, but you didn't take the results and put it somewhere. Now, why is this? It needs to be said that YAML at this point is still in preview and will improve over time. So eventually, hopefully sooner, this will contain that. So what do we do about it? We need to add some YAML to this. Well, there's a couple ways we can do that. One is we can say we want to publish the artifact, and we can view the YAML for that. So for any of these tasks that constitute the build, we can look at the YAML. So here's the YAML that will do that. So I'm just going to take this and copy it, bring it over here, and put it in the YAML for the build I want to use. Another way to do it, if I click Show Assistant, here's a number of tasks, including, if we scroll down, the Publish Build Artifacts task. So if I just double click on this and then Add, I can add that YAML in here. They're not 100% the same, so I'm going to use the one from the classic build. Okay, and then the last thing that I want to compare the YAML to the classic build is this automatically is triggered when there is any code written to master, whereas in the classic, you have to come to triggers and turn that on by enabling continuous integration. Now at this point, these two build definitions do the exact same thing. Now I don't actually need two of them, so I'm only going to run the YAML one. Okay, so I'm going to save this and run this, and we'll see what happens. It triggers a build. Okay, so if I click on this, I can actually watch it. Now, granted, watching builds go is not anybody's idea of a good time, but when you're learning and you want to know what's happening, it's actually quite instructive. Also, this build takes about 1.5 minutes, so it's not too terribly bad. So what happened is we waited for an agent to be available, a machine somewhere in this pool running in the cloud. Once that's available, the job initializes, tasks get downloaded, code gets checked out. Then we update NuGet, the latest version of NuGet. Then we do a restore for all our packages. Okay, that's happening. Then we do a build. Now remember, this build agent is a VM running Visual Studio 2019. So it's using MS Build, obviously. So all of this is going to look very familiar because it's essentially the same thing you do on your machine when you build solution. So all of that should look familiar. And again, this takes about 90 seconds. Your build might take longer. It might be a 5-minute build. It might take 10 minutes to run all your tests. You're certainly not going to sit here staring at this. And one of the benefits is you're not expected to. You've handed this off to a machine sitting somewhere, a VM from a pool of VMs available, and that machine is going to do all the work for you. So all the tests are run. And then in 1 minute and 19 seconds, this works. Okay. So now, if we go back to here, we can see the job succeeded in 1 minute 19 seconds. If we look at the tests, we can see that all of the tests passed, and life is good. Okay. So now, we said that every time we check into code into master, we're going to do a build. So let's see this happen again. Or let's see this be triggered by checking in code. So if I pop over to Visual Studio, let's make a change to some code here. I'm going to come into the home controller, and I'm going to change the view bag message. Save that, then I'm going to check this code in. Check this code in by clicking here. Put a comment, updated about view bag message. All right, let's commit it. Let's push. Now what this does is it pushes the current branch, and this failed because since I created a build, I need to do a pull first. Usually when doing this demo, I remember to do that. Occasionally I don't. So let's try this again. Updated about view bag message. Now let's push. And now this gets pushed into master in my Azure DevOps repo, which, because I've set up continuous integration, kicks off another build. Now, we could sit here and watch this for a while, but while that goes, let's look at a couple other things. An additional thing that happens when a build is kicked off is that when it succeeds or potentially fails is you get mail. So here's the scenario. You write a bunch of code, you test it locally, you check it in, and then that builds the entire application. Now, right, think about this. On your machine, you've got the code you're working on, you've got the tests you're working on, you've got the latest version of everything as of the last time you pulled everything down, but you're focused on your code. You don't want to have the entire application necessarily sitting locally. You're really interested in stuff you're working on, right? Or maybe you're doing a PR. You've got a branch and you're going to do a pull request. So everything works on your machine, and then you check code in, and what's built is the entire application. Now, it's entirely possible that you've written some code that breaks somebody else's code, or somebody wrote a test that you didn't get updated. Now, the code you wrote working on the old version of the test fails the new version of the test. Anything can happen to break the build. So the idea is that you check in code, and then you run a build. You run the entire application, not just your piece of it, but the entire application as it stands with everybody's code. And this is still queued. It's not running. OK, so what we'll do at this point is the producer will speed this up a little bit so we don't have to actually sit here and watch. And we see that the job failed, apparently. Now, if we were watching carefully, we would have seen somewhere in here that VS test, that task failed. And there's a hint in here. I saw as it was scrolling by some red, a test failed. Now, again, I'm not going to look at that. But if I come back here, I see that the test failed. And if I go to look at the tests, it is because a test failed. And then in addition, I get an email that tells me that the build failed. And the reason the build failed is that a test run failed. Okay, again, I can come back here, view the results, which takes me back to here. Right, and I can click here on About, and I can see exactly why this failed. Okay, so again, the beautiful thing about a build pipeline is that every time anybody checks in code, we can do a build of the entire application and make sure that things one person's created or worked on don't interfere with another, and that the entire application builds. Now, if you're the only one working on this, it's still useful to do if it's a complicated application. Now here, of course, it's a simple MVC app, and you might be sitting there and saying to yourself, well, yeah, no kidding, Green. If you would just run all of your tests before you checked that code in, you would have discovered this. So it is not the case that the beautiful thing about Azure DevOps is it means you don't have to run your unit tests. I'm just choosing this as a simple example. The beautiful thing is that once I check in code, the entire application gets built, and then we can see if it still works. Okay, I think this is a good place to stop. We'll pick this up again in our next episode, where I think I might show you one more thing about build pipelines, but then we'll move on to release pipelines. So I hope you're enjoying this so far. We'll see you next time on Visual Studio Toolbox.